Now that you know what matter is and the basic structure of an atom, we're going to talk about the different states of matter, which should be hopefully a little bit familiar to you. So we're going to start off with solids. Solids always have a definite shape and a definite volume, meaning that they don't change. So, a coffee mug has that shape. It doesn't change size. It's always going to be that way, unless, of course, it gets broken. If we were to zoom down and be able to look really, really closely, we would see that the molecules are really tightly packed together and they all move because all molecules, everything is moving. We just can't see it, okay? So if we were to get really, really close, we would see the molecules there. They would be moving just a little bit, but because they're moving so little, that ends up being a solid form, okay? Um, There are also a couple of different kinds of solids. It's called amorphous solids and crystalline solids. Crystalline solids look like this. Notice how there's a nice pattern here, okay, to the structure. There's still movement, but this is a very regular repeating pattern. This would be like an example of salt or sugar, okay? Things that kind of have that normal fixed shape. This is what would be called an amorphous solid. And notice how we don't have that fixed pattern. And notice how it's kind of some of it squished together, some of it spread apart. Things like this would be cotton candy, for example, right? How that bends and it stretches, but it's a solid. Rubber. This would be like an example of rubber. Even glass, because glass is kind of a weird one. It's a solid, but it used to be liquid, right? So this is what amorphous solids look like, and this is what crystalline solids look like. Now for liquids. Liquids have no definite shape, right? They take the shape of the container. You can take this bottle and pour it into this one. You still have the same amount in both, so that's a definite volume. But notice how the shape has changed because they take the shape of their container. If we were to zoom down close to the molecules, we would see that they're still vibrating because all molecules do, but they're vibrating more than solids, and they're not just staying in one place. They're moving around a little bit, which is why liquids flow, because their molecules are kind of flowing and moving around. Next, we have gases. Gases have no definite shape and no definite volume. So you can think about this like a balloon animal. Okay, if I want to blow up a balloon to make a balloon animal, first the air is in the room and it takes the shape of the room. And then I breathe it in, and then the air takes the shape of my lungs. And then when I breathe it out into the balloon, now it takes the shape of the balloon. And once I close out that balloon, I can twist it into all kinds of different shapes and make that gas change shape, okay? And you can squish a balloon and make it compact, right? So gases, they don't keep their shape and their volume changes. If you're noticing the pattern here, if we were to zoom in really, really close, the molecules of a gas vibrate way more than solids and liquids. They fly about everywhere, which is why gases are spread so far apart and they don't have this definite shape and this definite volume. There's another state of matter called plasma. We're not going to really talk about that in this class, but basically you can think of plasma as like a super duper hot gas and the electrons are all gone. And because the electrons are gone, they behave differently from gases and they just kind of do some funky things. Some examples of plasma, like fire is plasma, lightning is plasma, the sun is plasma, okay? Again, we're not going to talk about, I don't want you to really worry about that so much, but I just wanted to mention it because it is technically a state of matter. If we're to look at the states of matter, well, what's the main difference between solids, liquids, and gases? And it ends up having to do with the energy. So if you take a solid and you add some energy to it, guess what? The molecules are going to move around more. And if they move around enough, they're going to become a liquid. And if you take a liquid, if you add enough energy, the molecules are going to move around more and they're going to become a gas. Now, we're going to talk about this more later, but think about like if you take ice and you heat it up, what happens? It melts. Ah, that's taking a solid and adding energy and it becomes a liquid. Okay, so basically, as you add more energy, you're going to go to the right in this diagram. And if you were to take away energy, it would go to the left. So let's think of the reverse of what we just talked about. If you have water and you take away energy, aka make it colder, then what happens? Oh, it freezes into a solid. Okay, so the energy that's added make the molecules move more, and that will make them go to the right. Or the energy that's taken away would make the molecules move less, and then you would move to the left in this diagram. If you have any questions about this, this is in your textbook in chapter 2.1.